Hey everyone. So I just want to do I want to do three things today. I kind of want to review some of the stuff that we've been talking about in the last couple of videos. I would like to say a little something about some trig identities. Remember, they were the third third magic secret of trigonometry. And then I'd like to practice the hell out of stuff like this. Okay, so let's start. Will you write down sine theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta? And I would like to know, without looking in your notes, because you really do need to know these. No notes on quiz or test. Okay, I want to know on the unit circle and off the unit circle. Okay, and what I mean here is that sine, for example, off the unit circle is opposite over hypotenuse. And on the unit circle, that's going to be our y value on the unit circle. So will you fill in the rest of this? I want to pause your video, give it a go, and then you can compare answers. Okay, so cosine, that's adjacent over hypotenuse. And on the unit circle, that's the x value. Tangent is opposite over adjacent. And that could also be sine over cosine. Tangent is sine over cosine. And what is sine over cosine? Well, sine is y, cosine is x, and so we have y over x. Cosecant is the reciprocal of sine, so this is hypotenuse over opposite, or 1 over the y value. Secant is the reciprocal of cosine, and so that's going to be hypotenuse over adjacent, or 1 over the x value. And cotangent is the reciprocal of tangent, so we're going to have adjacent over opposite, and that's going to give us x over y. We definitely need to know this. Oh my goodness, we need to know this. All right. Next. Yeah, how about this? How about secant of 47 degrees? And no, that's not a unit circle value. Because this isn't a unit circle value, and because you're not living in the last century, but instead this century, we want to use the magic box. This is degrees, so please make sure that your mode is set on degrees. Number one reason why people blow trig quizzes, they leave their, they don't pay attention to the unit. But we need ours in degrees. Now, what are we going to do about secant? Well, I know that secant is the reciprocal of cosine. So I'm going to find the cosine of 47, and then say that secant is 1 over that cosine of 47 degrees. Okay, so cosine of 47, I get this number, but secant is 1 divided by that number. 1 divided by our answer, and I get that secant of 47 degrees is 1.466. Right. No, that's not the x value or the y value. It's the reciprocal of the x value. The point here being, I should be able to do this on my calculator too. What about the now, what about cotangent pi over 7? Again, this is not something I know on the unit circle. I know tangent but I don't know pi over 7. Well, I know that cotangent is 1 over the tangent. It's the reciprocal. So if I on my calculator say, hey, what's the tangent of pi divided by 7? Well, wait a second. Pi over 7, that's not degrees. Mode, radians. Oh, yeah. So the tangent is this number. Please don't round. Please don't round until you're done with the problem. I need to do 1 divided by this number. 1 divided by that number. And I get 2.077. Okay? There. So we should be able to do this stuff on our calculator. I don't have a secant or a cosecant or a cotangent button here. And see these things here in yellow? These are not. This is not cosecant. This is inverse sine. This is inverse cosine. This is not the reciprocal of cosine. This is not the secant button. No, no, no. This is later. We'll be dealing with these yellow buttons later. Right now, we're just using these, and I definitely don't see secant, cotangent, or cosecant. Okay? So, on the calculator, good. Now, this. This is just going to be sort of a little introduction thing, where I know that the unit circle is x squared plus y squared equals 1. Okay? That's our unit circle. Now, didn't we say a little while ago, at the beginning of this video, that x on the unit circle is cosine of theta? And so if I have x squared and x is equal to cosine, then I need cosine squared. And what's the y value on the unit circle? What trig ratio was that? We said that the y value here is 1. That's going to be opposite over hypotenuse, which is sine. But our y value is being squared. And so we get this. So this thing, sine squared theta plus cosine squared theta equals 1. This is called Pythagorean identity. Okay? This is always true. And you'll need to know your Pythagorean identities, not for this unit. But I do want to introduce them now to get you ready. They will be coming. There should be an identities handout in Teams already waiting for you. And not only will you need to know these, like here's this, but hey, you know, I could subtract cosine squared from each side and get that sine squared is equal to 1 minus cosine squared. Or, instead of subtracting cosine squared, I could subtract sine squared from both sides and get that cosine squared is 1 minus sine squared. Now, Pythagorean identity and these two rewritten versions of the Pythagorean identity. And really, what needs to happen is you need to be able to see this and say, oh, I know that's cosine squared. I don't expect that today. But by the time we get into our trig identities unit, which is after our trig graphing unit, yeah, you're going to need to be able to say, oh, cosine squared, that's 1 minus sine squared. Or, oh, look, 1 minus cosine squared, that's sine squared. Backwards and forwards and all of these. In fact, I want to do something else here. Let's divide everywhere by sine squared. Sine squared over sine squared is 1. Cosine squared over sine squared is the same as cosine over sine squared. Well, cosine over sine is cotangent. And the 1 squared. What's 1 over sine squared? Well, the reciprocal of sine is cosecant squared. Okay, so here's another Pythagorean identity. When we divide all of these by sine squared, we get all of these. And of course, not only do you need to know this one, but you also need to know the rewritten versions, like cotangent squared theta equals cosecant squared theta minus 1. Or cosecant squared theta minus cotangent squared theta equals 1. So these are just rewritten versions of this. You need to know all three of those. And finally, what if we were looking at our unit circle? Sine squared plus cosine squared equals 1. And instead of dividing everywhere by sine squared, we divide everywhere by cosine squared. Sine over cosine, tangent. Ooh, sine squared over cosine squared, tangent squared. Cosine squared divided by cosine squared, that's 1. And 1 over cosine squared is secant squared. Okay, so what are the other ones we need to know? Well, I do need to know that tangent squared theta equals secant squared theta minus 1. If I subtract this 1 from both sides, that's what I get. Or 1 equals secant squared minus tangent squared. Right? If I subtract tangent squared from both sides of this equation, I get this. And you need to be able to recognize this, and you need to be able to recognize this, and you need to be able to recognize this. In fact, we've talked about 9 different, or 3 different Pythagorean identities, but also 6 more rewritten versions of them. And I used to ask students just to do the basics. By basics, I mean you need to know sine squared plus cosine squared equals 1. Oh, by the way, if you do this, I'm marking it wrong because it's a sin and cos is ahead of lettuce. Sine of what? Sine of theta. Cosine of theta. That'll work. X. I don't care what you put for. You know, if you could draw a little picture of a boat plus cosine squared, a little picture of a boat equals 1. That works, sure. You just need to know this. So please, you may want to flashcard some of this stuff. Or you may want to write it out each day, just to make sure you're comfortable with it. All right, now, that in mind, let's look at this problem. We're told that 1 plus sine theta times 1 minus sine theta. And so we know how to FOIL. So let's FOIL. We get 1 minus sine theta plus sine theta, and positive sine times negative sine is negative sine squared theta. Okay, well, let's tidy this up. Minus sine plus sine, they cancel. Oh, 1 minus sine squared, I know that from my Pythagorean identities. What is it? Sure, it's cosine squared theta. And so again, third magic secret of trigonometry is know your identities. You need to be able to see this and say, oh, I remember that 1 equals sine squared plus cosine squared. And if I subtract sine squared from both sides, I get 1 minus sine squared equals cosine squared. Okay? Why don't you try this one? See what you can do with this one. We've got 1 plus cosine theta, 1 minus cosine theta. Please FOIL and simplify that expression. Okay, did you FOIL? Did you get 1 plus cosine minus minus cosine squared theta? Did you combine like terms and end up with 1 minus cosine squared theta? And what is 1 minus cosine squared theta? Yep, it's a rewritten Pythagorean identity. That's sine squared theta. Done. Okay, so that's the new stuff. Actually, one last one. It's a calculator question. I meant to do this earlier. What if they tell me that my angle theta equals 1/4, and I want to know the cosine of 1/4? Now, with a trig function like cosine equals cosine x, what I'm plugging in is an angle. And if I'm on the unit circle, what I'm getting out is the x value. The x value of that angle. So that's the angle of 0.4. 0.4. Do you see a degree symbol there? No. Which means this is the cosine of 0.4 radians. So when you look this up on your calculator, go to the mode and make sure you're in radians first. Yep. So I want cosine of 0.4. There you go. Cosine of 0.4, or the x value for this angle, is 0.921. And of course I'm rounding to 3 decimal places. This is the x value for this angle. Good. Don't be freaked out. This is radians. Do make sure that your calculator is set on the unit that it's supposed to be. So now I'd sort of like to do some high-speed stuff. So let's see how quickly we can do these. I believe this is the last. Yeah, this is the last thing I want to do, but it's a bunch of problems. Okay. Whoa, look at them all. Okay, cosine 5 pi over 4. If you need to have your unit circle out, you can. If you need to have your list of trig ratios, like that cosine is adjacent over hypotenuse, or on the unit circle, cosine is the x value, that's fine too. But really, or tomorrow, day after tomorrow, yeah, no more notes, no more unit circles. Okay. Okay, so cosine is the x value at 5 pi over 4, and I get negative root 2 over 2. How about the sine of 7 pi over 4? Okay. 5, 4, 3, 2, 1. Well, I know that this is in fourth quadrant, and sine is the y value. Over 2. How about the tangent of 3 pi over 4? Tangent of 3 pi over 4. 5, 4, 3, 2, 1. Okay, so I'm thinking about 3 pi over 4. That's this one here. It's got the ordered pair of negative 2 over 2, coming over 2 over 2. And I know the tangent is the y value over the x value. So that's going to be root 2 over 2 divided by negative root 2 over 2. I should end up with negative 1. The tangent of 3 pi over 4 is negative 1. How about this one? Secant 2 pi over 3. What is secant the reciprocal of? Secant is the reciprocal of cosine. So I want 1 over the cosine of 2 pi over 3. Cosine of 2 pi over 3? 5, 4, 3, 2, 1. Cosine is the x value on the unit circle. You want to know the x value at 2 pi over 3. That's here. X value is the shorter one. And so I know this is 1, negative 1. Cool. Oh, but we want secant. And so the secant of 2 pi over 3 is just going to be the reciprocal of that, negative 2. Okay. How about the cosecant of 7 pi over 6? 5, 4, 3, 2, 1. Well, I know this is the same as 1 over the sine of 7 pi over 6. And the sine of 7 pi over 6, that's this y value, negative 1 half. 1 over negative 1 half. So when I flip and multiply, I end up with negative 2 over 1. So this cosecant of 7 pi over 6 is negative 2. Okay. How about cotangent 3 pi over 2? Okay. 5, 4, 3, 2, 1. Well, there's a couple of different ways we can do this. We can know that on the unit circle, cotangent is x's over y's, and the x value at 3 pi over 2 is 0, and the y value at 3 pi over 2 is 1. 1 negative. And so 0 divided by negative 1 is 0. That's one way to do the problem. You could also say, well, I don't know about cotangent, but I know tangent of 3 pi over 2 is going to be 1 over x. So the y value is negative 1, the x value is 0. Uh-oh, that's undefined. But wait, I don't want this. Right? I'm really trying to use this to help me find cotangent. Well, isn't cotangent the reciprocal of that? Okay, so what's the reciprocal of that? And that's going to be cotangent pi over 2 is going to be 0 for negative 1 or 0. Okay, so a couple ways to know that. Man, there's another way to know that. Because of the reciprocal identities, I know that cotangent is cosine over sine. Cosine of 3 pi over 2, sine of 3 pi over 2. And you make up the 0. So we have 3 different ways to figure that out. And you should be comfortable with at least one of them. Okay, how about this one? How about cosine of pi over 6? 5, 4, 3, 2, 1. Okay, cosine is the x value of pi over 6. The x value is negative over 2. How about the sine of pi over 2? 5, 4, 3, 2, 1, and 1 is the answer. You want the y value of pi over 2. There you go. Cosine of pi over 2, what do you get for that? 5, 4, 3, 2, 1. Well, cosine is the x value, and the x value of pi over 2 is 0. Right? So what's that make? Tangent of pi over 2. 5, 4, 3, 2, 1. Well, we know that tangent is sine over cosine. The sine of pi over 2 is 1, and the cosine of pi over 2 is 0. That's undefined. And you know what? That makes sense because on the tangent graph, so, 2, I can see that at pi over 2, this is pi over 2 here, it's vertical asymptote. Oh, wait. Yeah, tangent has a vertical asymptote at pi over 2. That's why we're saying tangent to pi over 2 is undefined. Remember, 0 over 1 is 0. 1 over 0, undefined. They are not the same thing. Think about this as you and pizza. There are no pizzas sitting on the table. How much pizza does one person get? One person gets no pizza because there were no pizzas on the table. But if there's one pizza on the table and no one comes to eat it, what's that equal to? That's undefined. We can't talk about that. Okay, so let's mosey along here. How about cosine 11 pi over 6? 5, 4, 3, 2, 1. Well, I know cosine is the x value, and the x value of 11 pi over 6 is positive root 3 over 2. Hey, what about the secant of 11 pi over 6? 5, 4, 3, 2, 1. Well, secant is simply the reciprocal of cosine. And so we want 1 over 3 over 2. So the secant of 11 pi over 6 is going to be 2 over root 3. I would be fine with that on a quiz. However, you're going to really want that. So we get 2 root 3 over 3. Excellent. Oh, wait. Okay, I'm going to move on. Sine of 5 over 3. 5, 4, 3, 2. Hurry, the ice weasels are coming. 1. Sine is the y value. The y value at 5 pi over 3 is negative root 3 over 2. What about the cosecant of 5 pi over 3? Well, cosecant is the reciprocal of sine. Look, I know you want this to be the reciprocal of secant, because this is cosecant, just like you want cosine to be the reciprocal of sine. No, sorry, those aren't reciprocal functions. They are, though, co-functions. And we'll be talking soon about co-function identities. Functions that are co-functions, like secant and cosecant, or tangent and cotangent, sine and cosine. Those functions have interesting relationship with each other. Okay, cosecant 5 pi over 3, 5, 4, 3, 2, 1. Cosecant is simply the reciprocal of this. I just need the reciprocal of this. Positive 2 over 3. And you might want to rationalize that. 2 root 3 over 3. Okay, and then finally here, cotangent 5 pi over 3. What do we get? Well, that's the same as cosine 5 pi over 3 over sine 5 pi over 3. And so what is the cosine of 5 pi over 3? Well, the cosine of 5 pi over 3 is the x value at pi over 3, and that's going to be negative 1/2. Sine of 5 pi over 3, that's negative root 3 over 2. And if I do the flip and multiply, I get that that's going to be negative 1 over root 3. And if you rationalize it, it's negative root 3 over 2. Okay. So that's the review of positive angles. Now I want to review negative angles. Cosine of negative 3 pi over 4. Okay, so let's think about negative 3 pi over 4. Here's 0. Here's negative pi over 4. Here's negative 2 pi over 4. Here's negative 3 pi over 4. Here we have negative 4 pi over 4. Negative 4, 6, 4. There's negative 7 pi over 4. And this is going to go to negative 8 pi over 8. 8 pi over 4. So what do we want to know? We want to know the cosine of negative 3 pi over 4. Well, here's negative 3 pi over 4. And so what's the cosine value? Well, we know the cosine value is the x value at that point. I'd like to know the x value at those 2 points. Okay. Cosine of negative 3 pi over 4. X value at negative 3 pi over 4 is negative 2 over 2. Okay, what about the sine of negative 7 pi over 6? You know, feel free to think about this. What does it look like? Well, that's my data. Negative 7 pi over 6. And here we want to know the sine. What's the sine of negative 7 pi over 6? Well, what's the ordered pair here? The ordered pair here is this is negative 2 and then the sine is the y value. So okay. How about so tangent is the same as sine over cosine over 4. Well, where's negative 3 pi over 4? 1 pi over 4, 2 pi over 4, negative 3 pi over 4. Okay, so I know that both of these are negative root 2 over 2. A number divided by itself, we're calling that 1. So tangent of negative 3 pi over 4 is 1. Excellent. How about secant of negative 7 pi over 6? Secant of negative 7 pi over 6. Oh, and by the way, if this negative angle gives you stress, like you could do it when it was positive, but you can't do it now while it's negative, and you don't like that sort of counting around in the opposite direction thing, use the coterminal angle. How did we find positive coterminal angle? We added 2 pi to that number. Okay, let's make a common denominator. 12 pi over 6 minus 7 pi over 6, which is going to give me 5 pi over 6. So this secant of negative 7 pi over 6 should be the same as the secant of 5 pi over 6. So, yeah, and all I have to do to get away from this negative angle was to add 2 pi. I'm just going to add 2 pi to make it work. And use that coterminal angle. Well, I still don't know what the secant of 5 pi over 6 is, but I know that the cosine of 5 pi over 6 is negative root 3 over 2. And I know that secant is the reciprocal of this. So, secant of 5 pi over 6 is going to be negative 2 over root 3. And when I rationalize, we get negative 2 root 3 over 3. Okay? So, what is that one? Cosecant negative 2 pi over 3. And, use the counting method on your unit circle, or use coterminal angles here to find what the cosecant of negative 2 pi over 3 is. Negative 2 pi over 3 plus 2 pi is negative 2 pi over 3 plus 6 pi over 3, and negative 4 pi over 3. So this is going to be the same as the cosecant of 4 pi over 3. And I know that sine is the reciprocal. So what's the sine of 4 pi over 3? Sine is just the y value. The y value of 4 pi over 3 is negative root 3 over 2. And therefore, cosecant must need to be the reciprocal of sine. So negative 2 over root 3. We end up with negative 2 root 3 over 3. Good. No way you can make this much practice. And cotangent negative pi. Please tell me what the cotangent of negative pi. 5, 4, 3, 2, 1. Okay, so negative pi is here. Positive pi is here. The ordered pair here, is negative 1, 0. Cotangent is x over y, traditionally. And so in our situation, it's negative 1 over 0. Can't divide by 0. That's undefined. Okay? How about cosine of negative pi over 6? Cosine of negative pi over 6. Okay, so here's negative pi over 6. And I don't know what cosine is. Cosine is the x value. Now, I see that the x value here is root 3 over 2. But if you're not sure about this, again, you could add 2 pi to that. Negative pi over 6 plus 12 pi over 6 is 11 pi over 6. And while you may not know the cosine of negative pi over 6, it's gotta be the same as the cosine of 11 pi over 6. Okay, so 11 pi over 6, the cosine is root 3 over 2. Okay. How about the sine of negative pi over 6? What's the sine of negative pi over 6? 5, 4, 3, 2, 1. You should get negative 1 half. So, negative pi over 6 plus 5 is 11 pi over 6. That's the y value 11 pi over 6. That's my answer. Okay. Let's just squeeze in just a couple more. How about sine of 7 pi over 2? Okay, so we can do this one in two ways. We can count the pi over 2's. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. So there's 7 pi over 2, and we want the sine of that. Well, that's going to be the same as the sine of negative pi over 2, which is also the sine of, is that true? 2 pi. 8 over 2, no, 2 pi. 1 times 2. No, sorry about that. Yes. I mean, kind of what I'm going to say is, why don't we use good calculations? Why don't we subtract 2 pi? So 3 pi over 2. So this that I'm comfortable with could also be the sine of 3 pi over 2. And what is the sine of 3 pi over 2? The sine of, what is the sine? Is there I do like this idea. I do like the idea of saying, okay, I'm looking for the sine of 7 pi over 2. I can't find that sine, but I do know that I could do the sine of 3 pi over 2. That's going to be, what angle has this help us? 3 pi over 2. Sine is the y value, and the y value of 3 pi over 2 is negative 1. Okay. How about sine of 7 pi over 3? You know, again, I don't recognize this from the unit circle. So I'm going to subtract 2 pi. 7 pi over 3 minus 6 pi over 3. So this is the same as pi over 3. Okay, and what is the sine? The sine is the y value. What do you think? Is it starting to make sense? Does it start to feel doable? How about the sine of 9 pi over 4? You could certainly count pi over 4s. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4. This is what we would end up. And we're looking for the sine. And what's the sine? The sine is the y value there. And we should end up with root 2 over 2. Now, if you didn't particularly like that, that's fine. Let's instead take 9 pi over 4 and subtract 2 pi. Now, maybe this is too big. It's outside of our unit circle. So to get something back on our unit circle, I'm going to subtract 2 pi, which is 9 pi over 4 minus 3 pi over 4. Nope. Actually, 8 pi over 4. There we go. And so we end up with pi over 4. So this is the same as there's something wrong there. try again. I want you to take 9 pi over 4 and subtract 2 pi. That's 9 pi over 4 minus 8 pi over 4, which is 1 pi over 4. And so what's the sine of 1 pi over 4? Oh, I see. That's just root 2 over 2. How about the cosine of 23 pi over 6? Well, I love the counting method here. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6. Oh my god, I'm not there yet. I'm not even halfway there yet. So instead, can we take this 23 pi over 6 and subtract 2 pi? That's 23 pi over 6 minus 12 pi over 6. So 23 minus 12 is 11 pi over 6. And what's the cosine of 11 pi over 6? Well, 11 pi over 6 is here. And the cosine value here is negative root 3. Cosine of 11 pi over 6 is positive 3 over 2. Good. All right. So when I have a negative angle, sine of negative pi over 6, I want to add 2 pi to that. I don't want to use the coterminal angle. So that's going to be the sine of 7 pi over 6. Because I added 2 pi to that. And I know the sine of 7 pi over 6 is negative 1. Nice. Yeah. And if I'm given a negative angle, I'm going to add 2 pi. But if I'm given a very big angle, I'm going to subtract 2 pi until I get to a place that's good. I may not recognize this, I may not be comfortable with negative angles, but if I use my coterminal angle knowledge and add 2 pi to this, I get this sine function. Okay, well, I hope this is helpful. I hope you're starting to sort of gel on this, and if you're not, you gotta practice it some more. Have a wonderful day, everyone.